All right. So, hey Amanda, hey Lisa. Hope you guys enjoy this patch. So, Amanda, in class, or in discussion, I said that I would make a patch that can generate a song based off of certain values inside of a voice. I wasn't. I thought about doing that, but after fooling around more and kind of just exploring different ideas, I decided to go another route and I guess kind of um, get back to old school sampling. So kind of like what Zach Kaiser talked about in his guest lecture about how and kind of about what I wrote about the in my blog post about his lecture. I talked about how technology has the current technology has rendered old technology kind of obsolete by the sheer just um, more. There's just way more memory, way better computing power. Everything's just faster and able to hold more memory nowadays, and so it kind of rendered his Dr. Sampler. He just basically doesn't use it anymore. So I wanted to see if I could kind of make my own Dr. Sampler um, piece of hardware or technology using this program called Pure Data, which we've been working on and learning about in Music 171 with Miller Puckett, and it's a really cool program. It's the same program that I talked about in lecture. Okay, so here are my 8 different banks, and in it I already have some stuff recorded in all of them. You can see when I click on one of the abstractions, it enters that that little bit there. Okay, so right now I have these two controls up here in the top left. The master tempo, that's the tempo. That's the rate at which the samples are played, uh, and the tempo is on the horizontal slider, and then the volume. Each volume is on the vertical slider, and both of those have master control up here. You'll also notice I have these little boxes that you can toggle on and off, and that's how you can isolate a certain voice. Like let's say we just want to hear from bank 1, so I'll click off all the other ones. Let's turn it up a little bit too. So this sample, this guy right here, is a little sample. I just recorded a tiny little snippet of a Pinback song. It's a band that I like, Pinback. I forget which song it was too, but we can record a new one right now. How about that? So let's go to iTunes. Let's go. There's Pinback right there. Let's do. I like some of the guitars in I'm a Pretty Lady. So to record, simply hit record. Let's record right when the bass starts playing. That's good. I like that a little bit. Now let's see what we got. Now this sample isn't very long, so yeah, see, it only grabbed a little bit of it. And by a little bit, I mean not very long at all. So you'll notice, well, I mean I have to point it out, but right here, see this number? This is the sample size. So that's how big the sample can be, how much time I can record. So over here in bank 8, it's notice it's 100,000. The other one was only 44,100. So this sample can grab a lot more. Right now, in in uh, in this one, I can you hear that? Anyways, let's get rid of that and let's get a cool bass. So let's see what we got. Oh, see, it's very small. Say right around there. That's close, as close as it's gonna get. So, anyways, I recorded a bunch of stuff, just like me making silly noises. That's what this one is. That slow noise is this guy. And then you'll notice that that actually sounds really cool. Just that pinback sound. It's really cool. This guy right here. So that noise, that's the opening chord from Phantom of the Opera's Overture. And it's funny because I can kind of like play it. Do 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 do. Anyways, yeah. So I just wanted to kind of explore some concepts that we talked about in music 171, which is phase shifting, which is basically messing with the tempo and seeing how it affects the pitch. But as far as how this relates to Vis159, of course, and obviously this is all done on technology. This is done via this program, Pure Data. This guy right here. So it was all written by. All this was patched together by yours truly. So I can explain yeah. So really quickly, I guess. So we get the number. This just number. I guess 0.6 right here. That's fed into. See right here. See that. See the line. It's pretty. It's pretty intuitive. So the line goes into this inlet. So that's the middle inlet, and that guy is going to be right here on the left, or sorry, on the left inlet. This is we're looking at PD Bank right now. So this line right here is this inlet, and the record line, notice, goes to the right inlet. That's that inlet. Notice if I hit record. Well, I don't want to overdo that one. I'll show you right here. Yeah, we don't really care about this recording. So keep an eye on this guy right here. This little, it's called a bang. So when I hit this record, you're going to see this go black. See? And now we're recording. We just recorded that. See? Pretty cool, huh? Anyways, so what that did is that this is ADC, this object right here. This is always listening to what's happening, and this is a high-pass filter and a low-pass filter. This basically just to clean up the sound, and that sends it to this object right here, which writes it to this array. This is the sample, and then when this receives a bang, then it writes, because it's always getting input, but it's not always writing. It only writes when it receives, when that little guy goes off. And so I was talking about tempo, so that's read to this phaser object, which basically the phaser goes from 0 to 1 based on how fast, based on the number that's inputted to it. So I do some rapping stuff with not like hip hop rapping, but rapping, WRAP. I wrap the sound so it gets a little bit cleaner. I read from the sample this way, and then I read from the sample this way, and tie it together with the cosine waves. Anyways, and it outputs the cleaned up finished product out of outlet, and then that guy, that's this outlet, goes to this outbox, and then in here, let's open that up. That receive it's kind of looks messy, but this is where all the sound is, the thicker line, and that's so see this toggle. That's remember how I said that turns stuff on and off. Basically, when the toggle is on, it's outputting a 1. So when you multiply something by 1, it obviously stays there. But if it's turned off, then it becomes 0, and so that'll turn off that individual voice because it'll multiply it by 0. Anyways, that goes here, and this number right here, remember that's the volume of that particular voicing, and so that comes in over here and multiplies it by a certain number based on how loud you want it to be, and then this DAC, that's the output speaker. So that's when you want to listen to stuff, you hook it up to the DAC object. So, and then so this master volume, that's just an object. It says S master volume, so that S stands for send. So inside here, I have a thing that, or actually no, it's right here. All these volumes. See, they have to receive the master volume messages that are sent. So that's why they all respond to this. Same exact concept with tempo. Same exact thing. So that's about it. I mean, I just fooled around. Let's listen to what's happening. It's just cool messing around with the tempo. Anyways, that's my project. So I can email you, or this program, Pure Data, is, even though it has a high learning curve, it's pretty intuitive. So you connect these lines, and they do stuff, drag stuff up and down. But Pure Data, the program itself, is completely free. So I can send you a link on if you want to download it, because I'll turn in this video that I made, and that will be my final project. But I can also email you guys this actual piece, this file right here, and that way you can go in and make your own stuff, make your own samples, and get your own funny sounds out of it. So, anyways, I hope you guys enjoyed my final project. I had a lot of fun making this, and just doing silly stuff like goodbye. Let's see. Did not get it? Let's see. Maybe he needs the bigger one. Goodbye.
Goodbye. Goodbye. Goodbye.
Goodbye. Goodbye. There we go. Goodbye.
Goodbye.
Alright,
Goodbye.
we'll go out on a
Goodbye.
phantom chord.
Goodbye. 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 Goodbye.